Thank you, Jonathan. Hello, everyone. Yes, I'm going to talk mostly about what I've done for my PhD and what I'm also doing right now. So I'm going to talk about research foundations. I'm going to talk about pollination services and the beauty of pollinators. And I'm also interested in policy analysis. So the last part is not quite related to pollinators, but more about how to analyze different policies at a national and also regional scale. All right, so we live in a hungry world. We need to feed around 7.2 billion people. And it is forecasted that by the year 2050, we will need to feed approximately 9 billion people. So probably we would need to produce more food for that. Unfortunately, we're taking a lot of land for agricultural. So this raises the question, are we going to need more land to produce more food? Unfortunately, crop farming is one of the main drivers of deforestation, mainly in the global south. And these activities threatening around 4,600 species. And not only species, but this is also one of the main drivers of climate change. And also requires a lot of water. So I want to approach two research questions. How can we increase food production while we minimize the risks to biodiversity? And how are the trade-offs between food production and biodiversity conservation? So for my first chapter, I want to work with pollinators in a coffee landscape in Costa Rica. So why I want to work with pollinators in agriculture and conservation, because pollinators are very important for agricultural production. So there are different types of pollinators. We have bats that pollinate tequila, which is quite amazing. We have microflies, which also pollinate cacao and mango. We have butterflies and moths that are important for some crops like custard apple. But the main pollinator is usually bees and wild bees because they pollinate most of the crops that we consume. Unfortunately, there is a decline of pollinators, not only honeybees but wild bees. And wild bees are very important pollinators because they can increase or can even double some crops more than honeybees. So that's why we should protect or we should focus on wild bees. Usually, all the media attention has been focused on honeybees, but recently, most attention is getting to wild bees, which is great. So there are many drivers that are causing pollinators. Well, it's climate change, pesticides, but usually habitat simplification is one of the most important ones. So we have more simplified landscapes. We are impacting pollinators' richness, and therefore we also can impact the pollination services that they offer. So this shows that there is an important link between conservation and restoration of natural areas to increase pollinators' richness and abundance, and therefore also agricultural production. So this is just an example of the importance of pollinators. So wild bees require natural habitats because they usually do their nest in the leaves or some trees, or also in the soil of natural habitats. So when we have a crop that is quite isolated from natural habitats, bees cannot arrive to the crops and they won't be able to pollinate them. So in this study, they show that there is a negative relationship between forest distance and bee richness, and also a negative relationship between forest distance and the crop production. And there is a positive relationship between bee richness and crop production. So yeah, it is quite straight the relationship between pollinators and forest and conservation. So most of the studies, like this is not new, most of the studies have been trying to understand how pollination services can impact yields or the economic production of agriculture. but they usually focus on the economic aspect and they don't talk about the conservation. On the other side, there are many studies that are trying to understand which areas are important for habitat protection and pollination services. The main focus is conservation, but they don't put the economic aspect. And also, they usually overlook land use summation. So what I mean here is that they are more focused on the protection of natural areas, but they don't look forward to expand agricultural production. So for my research, I want to include these two sides. Although we want to protect all the remaining forests globally, this is going to be very difficult and it's going to be a challenge because there are so many socioeconomic conditions that make this impossible. Many farmers, especially from the global south, it is impossible for them to set aside areas for conservation or restoration because that would imply a high opportunity cost. So that's why it is so important that we need to understand where to produce food without impacting farmers. Where to produce food to increase crop production, but also where to conserve land without impacting farmers. So my first research question was how can pollination services affect habitat retention and agricultural expansion outcomes? And we want to develop a framework to provide habitat protection, agricultural development, by quantifying pollination services in a coffee crop. And why coffee? Because coffee can, despite the fact that it can self-pollinate, pollinators can increase from 10 to 30% yields. All right, so I had different objectives. So the first one was just to maximize coffee yields without caring about conservation. And the second one was to maximize coffee yields and at the same time maximize forest retention. So I developed different scenarios. I have a baseline where there is no objective, it's the current landscape and no action. The second one, we want to maximize coffee. The third one, we want to maximize coffee and we will ignore that pollinators are important. So the following one, we are including pollinators and we will consider that they're important to increase crop production. And the last one, we are going to make forest retention as an explicit objective. So we used typical Costa Rican coffee landscape. So in here we have coffee, the green is forest, and the yellow one is other land uses, which usually are grasslands and sugarcane. So we divided the landscape in small grids, 40 by 40 meters, and for each grid, we knew the coffee suitability, the potential yield, and the land use as well. I used integer linear programming to solve this problem. So we have an objective function. So basically, we wanted to maximize yield for some scenarios, and for other scenarios, we want to maximize yield and at the same time forest retention. And we used a scale factor in order to explore the trade-offs between these two contrasting objectives. All right, so this is just an example to show you how these models work. So we have a land cover. This is just an example. So we have here forest, and then we have different coffee areas. So we know that bees are living in the forest, and then they have different foraging distances or traveling distances. So we will have higher coffee yields when the coffee is adjacent to forest. But then we will expect that yield is going to decrease when coffee is very far from forest. So if we have our current landscape in Costa Rica, and we translate this image to the image in Costa Rica, we can see that there are many places that are so far from the forest that bees cannot travel there, and therefore we're going to have very low yields. So I used the data sets that were reported, that many studies report about the bee abundance and species richness in Costa Rica coffee landscapes. And this is what I have found. So we have objective 1, which is yields, and objective 2 field, which is forest. So this is the baseline, so you can remember how was the original landscape. So for the first scenario when we don't consider pollinators are important, what the algorithm is showing us is that we need to deforest everything in order to increase yields. But of course, we're going to lose all the forests. But when we consider that pollinators are important, we're going to even have higher yields, but unfortunately, we're going to deforest a lot. Like these small dots are small patches where this can live, but of course, this is going to show a very negative, or it's going to have a very, very negative impact for the second objective. So when I use forest retention as an explicit objective, and I use a scale value to see the trade-offs. So when I use a very high scale value, what this is showing me is that we should preserve everything, but this is a bad result for the first objective, which is yields. But then when we have a mid value, we are going to see that we can still increase forest yield and coffee yields, but we are not going to deforest everything. So it's like a balanced result for both objectives. So in summary, when we consider pollinators, we can retain 75% of forest area compared to the baseline, and we are going to increase by 30% of yields. So including pollinators in decision making is very important. All right, so I showed you this slide before. So I told you that there is a lot of regions that the coffee yields is very little. So maybe there's room for restoration. So for my second chapter, I want to explore how restoration could increase coffee yields and also conservation. So there's a study where they show that when we restore with just small patches of flowers nearby crops, crop production can increase and also be abundance. So in here, this is honeybees. So honeybees, they don't care about restoration because they can forage everywhere and they have their hives, so they don't need natural habitat. But bumblebees, after 4 years, they increase their abundance, so that was very important. And also other pollinators like overflies. In this study, they showed that at the beginning, the profit was negative, of course, because they had to spend money to restore these areas. But after some years, yields start to increase, and because they didn't need to invest more in the restoration, they will going to have different profits. So to explain that, so I want to explore if we could find a similar trend in a larger landscape, because this was a very small landscape. So this is what I explored in my second chapter. So how can pollination services affect habitat conservation, habitat restoration, and agricultural action outcomes? And I also create a framework. I use a very similar approach. I use scale factors to explore the trade-offs between these two different objectives. This model was a bit more complicated because I need to include the economic inputs, such as the coffee net present value, which is basically composed by the yield times the price minus the cost of producing coffee, also the restoration cost in Costa Rica, and we want to use a time horizon for restoration. So after doing a literature review on how restoration is produced in Latin American countries, we found that after 40 years, we can obtain similar biodiversity features from restored forest compared to natural areas. So I also developed different scenarios. The first one was that we gave more importance to restoration. On the second one, we gave more importance to economic profits. And the third one, we want to find a balance, a sweet spot between these two different objectives. And of course, we have a baseline, so we can compare all the results to the baseline. So in here we have our two different objectives, and this is the baseline, and these different dots are the scale values. So when we gave more importance to the profit, what we saw is that we are going to restore some parts of the coffee land and very small dots within the coffee area. So in here we see that compared to the baseline, we're going to increase profitability and also forest area, well, restored area. For the balancing scenario, as you can see, we are going to restore larger areas and in a more compact manner. And this is showing better results compared to the baseline. And when we have a huge importance for restoration, of course, the model is showing that we have to restore everything, which is not quite feasible, but maybe if an NGO is buying all the land, maybe that could happen. So this is the summary. This was quite interesting because this is showing that we can have good benefits from forest restoration and crop production if we restore also in a halfway compared to when we give more importance to profitability. So I hope that these frameworks can have partners, especially from the global south. Especially because in the global south, like when there is small landholders, we can see that if we increase pollination services, the production gap is going to be enhanced significantly compared to big landholders. So this is very important for yes, like these kind of countries in the global south. And now for the next part of the presentation, I'm going to talk about policy analysis that I did. So as you have seen, I love pollinators and bees are fantastic and are super cute. So I want to see how we could protect bees in Colombia because it's my home country. As I showed you before, pollinators are declining, so I want to see what kind of actions Colombia were taking to protect pollinators. So with some colleagues, we wrote a letter in Nature where we found that Colombia is part of the pollinator coalition. So many countries are gathering and are trying to promote policies to protect pollinators. And in 2018, many Colombian institutions created a roadmap to protect pollinators. So that was quite promising. However, they are not doing so well in the protection of pollinators because the Colombia Development Plan from 2019 to 2022 is very the targets to stop deforestation is really loose. So if they continue with those targets, that would mean that they could have more deforestation compared to 2017. And there's a lot of overuse of pesticides and many honeybee hives in the country are dying. In 2019, there were a law proposal where they want to protect natural habitats that were nearby crops, but unfortunately that law wasn't approved. And also the country wants to use glyphosate again because they want to destroy illegal coca fields, which is awful because that has a horrendous impact not only on pollinators but also in human lives. So yes, unfortunately, Colombia is not doing so well. Then I want to continue doing more policy analysis in Colombia. So this is not like now forget about pollinators, and I'm going to talk about other ecosystem services. So when we want to plan for multiple objectives with a limited budget, things could be quite complicated. And biodiversity, we're living a biodiversity crisis, and conservation is becoming an important objective for many governments. So for this particular chapter, I'm going to talk about how the government wants to protect biodiversity through a payment of ecosystem service scheme. So usually what governments do, they are trying to protect natural habitats that are in farms. So in that sense, farmers are not having a huge opportunity cost in that way. So many countries are creating now national policies to standardize the payment of services, and Colombia is one of them. So designing a payment of system services could be quite challenging because we have to include multiple things, not only biodiversity, but also budget limitations. So three main questions raised from this. So what kind of actions could the government invest? Where should the government invest? And does the type of payment have any repercussion of society? Because payment of customs services have been criticized before because have a negative repercussion to society. So what kind of action could the government invest? So there are different types of payment for existing services. Water is very important in Latin America in particular. Carbon is increasing in Latin America, and three of them are considering biodiversity. Where should the government invest? So this is really important. This was a paper produced by Williams in Colombia in the Orinoco region, and she was trying to understand, like this region, the government wants to increase agricultural production, which makes this region at risk. So what group did was to explore how to maintain existing services in the region and also to increase agricultural production. So if we just focus on one objective, which is water, agricultural production should be in the north and very aggregated. If we want to focus only on conservation and on carbon sequestration, agriculture should be more scattered. And if we want to focus only on biodiversity, agricultural production should be in the center of the region. So as you can see, we have different objectives. So that's very important to take into account for a policy. So does this payment have any repercussion on society? So how payment is when agriculture is more profitable than the payment, that means that the scheme is not quite fair to farmers. So usually what scientists propose is that the payment should be higher than agriculture. And also how accessible is the payment and the benefits. So usually in the past, now that's changing, but in the past, many big landholders were accessing to this kind of payments because they knew where like food contact, and also they had larger areas. So usually NGOs prefer those larger areas because we are going to preserve more. But many smallholders were excluded from those kind of schemes. So designing this type of schemes can be quite overwhelming. So I hope that with this framework, this could be less overwhelming. So I was trying to use these different objectives like biodiversity, water, carbon, and social equity with a limited budget to guide policy making in Colombia. So in 2017, the government released a national payment for existing services. So this is Colombia with the different land uses, and these are the areas where the government wants to prioritize for the payment. So there are some things that are good from the policy. They want to prioritize vulnerable people, which is good. They want to include fragmented systems. So that means that there's a biodiversity focus, which usually is not quite common in this type of schemes. And they want to account for water demand. But there are some missing important actions in the policy. So they actually didn't account for the economic cost of setting aside areas. They don't consider water supply or carbon supply, which is really uncommon on these types of schemes. Right, so For the framework, it had like three main components. The first component is creating scenarios with clear objectives to explore trade-offs among them. So in the first scenario, I just want to explore the trade-offs between existing services, carbon and water. For the second one, I want to explore the trade-off between existing services, so both of them, compared to biodiversity. And in the last one, I want to explore the trade-offs between ecosystem services and biodiversity come together compared to social equity. So the second component is to include all the inputs. So we have biophysical data. So we need to know the land suitability for crops and livestock. We want to know how was the supply and the demand of for water, because there is no demand for carbon, or at least there is no target active target in the from different regions in the country, and we have different economic data. So in the second component, when we have all the inputs, we want to have an optimization problem to solve an optimization problem. So again, I use different weights to explore the trade-offs between the different objectives. So I use the benefit cost ratio targeted analysis. So basically what I did was to divide the country in small grids. And for each grid, I knew the land use, the water, social and carbon supply, demand, and also the opportunity cost. And of course, these grids are not that big. This is just for the presentation, but they were like 1.2 kilometers square. So this is just a toy model to explain the model. So in here, let's say that we want to maximize existing services and biodiversity. So the red ones are important for existing services, and the gray ones are important for biodiversity. So we make a rank of them according to the importance, like how much benefit we can get from them. And remember that we have a limited budget. So unfortunately, we won't be able to select all the sales, but just the ones that are within the budget. So let's say that only these were selected. And the third component of the framework is to create a trade-off or Pareto. So we want to see all the options that we can get and explore, spatially, explicitly explore the solutions for the different objectives. So yes, I use these crops and livestock data. These are the websites where I took the data from. Yes, I collaborated with Dolores Armenteras. I don't know if you saw her talk last week, but she provided the maps for carbon and water, and I selected the maps from the government for the social equity and biodiversity. So this is the first result. So we have a spatial explicit opportunity cost map. So the dark regions are regions that are so expensive to make some conservation actions that we probably wouldn't invest for payments of ecosystem services there. But there are some light regions where there might be important for the investments, but we need to know if they are important for biodiversity and other ecosystem services. So in here, this is for the first scenario. So we have objective 1, which is carbon, objective 2, which is water. So as you can see, there are some regions where carbon and water are sharing. We saw that for carbon, usually we have more planning units in the south where the Amazon is located, which makes sense. Whereas for water, we have more regions in the Andes. And when we have a balanced solution in the weights, we can see that there is a mix between these two objectives. So for the second scenario, when we have biodiversity and ecosystem services, we can find that water, carbon and water share more regions in common. but it was interesting to find that carbon provide better solutions for biodiversity than water. So here we have more biodiversity compared to water. When we include social equity, so bear with me because this is a very complicated graph. So in here we have both water and carbon, and these different colors represent different dimensions of biodiversity. So when we had a great weight, or like the largest weight on biodiversity, in this solution, when we don't have any weight on biodiversity, when we don't care about biodiversity, the solution, the solution, and when we care in a balanced way about biodiversity is the solution. So in this sense, this is showing that when we don't care about biodiversity, we are going to have a high amount of water and carbon, which is a little bit counterintuitive. So for me, that was an unexpected result. But then we saw that there's a huge trade-off between biodiversity and social equity. So that's probably the reason why this is showing us this. But anyway, when we have a balanced way between biodiversity and the other objectives, we can still have good outcomes for all of them. So in conclusion, when we design for agreement-specific services, it's very hard, but we should take into account different objectives. A spatial placement opportunity cost is essential to prioritize limited resources. We can, yes, like knowing these trade-offs is important for decision making, because what we found as well is that these regions were not quite aligned to the regions that the government initially selected. So that's why it is so important to know, especially the trade-offs. And yes, these are the main components of the framework. And how much time do we have?
17.
All right. So now after my PhD, so I was quite overwhelmed about all the global pandemic. I was just wrapping my thesis up. And also, so I started to read more about how should we conserve more globally. And maybe some of you are not quite familiar with the spatial agreement. So this is an agreement that was produced from the conference Rio +20. So many countries gathered together, and they want to increase the production of environmental information and the participation of different stakeholders. But specifically, they also want to protect environmental defenders because, unfortunately, in Latin America, there are many environmental defenders that are threatened or even killed because of their important actions. So this agreement, many countries started to work on this agreement in 2012, but then in 2018, 33 countries were invited to sign and ratify the agreement. And this year, all the countries who ratified them need to implement that. So, yes, so far we have 12 countries that have already ratified and 12 countries that are pending for ratification. And unfortunately, Colombia is one of those that are still pending. So that's why I got interested in this topic. So now we wrote a policy perspective for conservation letters. We want to highlight the good things that this agreement has to invite the other countries to ratify. And also we want to identify the mechanisms that can help this agreement's implementation for those countries who has already ratified. Because this agreement is fantastic, it's the first legally binding agreement that makes that there's a huge opportunity for biodiversity and social defenders, the protection of social defenders. But the agreement is somehow a bit flexible. So we thought that the mechanisms were not quite explicit. So that's why we want to to explore these mechanisms. So in general, we found that there are different aspects of the agreement. So one is the democracy. So they want to increase public participation, environmental decision making, and the generation of access to information. So we found that there are technological-based, human-based, and nature-based mechanisms that could increase democracy. So, for example, just a small example was that in Brazil, the government usually in the 70s used satellite images to track deforestation, and usually the government was saying that they were doing very well, but of course NGOs thought that that was not true, and then they start to promote with not only NGOs but universities and even some people from the government to release that information because these satellite images were just used by the government. Other stakeholders couldn't access to them. So after that movement, and now these satellite images are freely available. So now it is easier to monitor deforestation in the Amazon in that country. All right, so for human rights, most of the mechanisms are, of course, human-based. So there are many consortiums of NGOs or organizations that are trying to promote human rights in the region. So, for example, this year, many indigenous people from Colombia and Brazil gathered together with NGOs from overseas, I think that from the US and France, and they're suing chain, the casino chain, because they're arguing that big production is threatening the livelihood and also where they are living. So hopefully they will win that battle. And another important aspect of the agreement is about cooperation and capacity building. So I think that many countries can try to reach different institutions or organizations like Microsoft who are training actually many institutions in artificial intelligence for grants. And also it is important to have like this is also a technological-based mechanism because they can aid storing biological data so people can access to this data, and that will enhance capacity building. But the agreement also has great opportunities for transboundary conservation. So these are the different countries who have already signed and ratified. So these ones are the ones, the dark ones are the ones who have already signed and ratified. The grays are the ones who are pending, and the white colors are the ones who haven't signed or not ratified. And as you can tell, that they are like all the countries are sharing so many terrestrial biodiversity or marine biodiversity that would be very important if they can ratify, because that would promote collaboration between countries. And when they have more collaboration, it's easier to make a better management of natural resources and biodiversity. And this is not only for biodiversity, but for other natural resources like river basins. For example, this is the Amazon, which is shared with 9 countries. So, of course, those 9 countries should work together to protect the Amazon. And yes, we found that there are like different provisions from the agreement that would promote the protection of transboundary species and natural resources. So to name a few, for example, big data could be very important. So they have already in place a network that is tracking the impacts on the Amazon. But for example, for this perspective, we were proposing to create a big GIS or a big data set that could track the different aspects of transboundary species. And now I'm starting to create some collaborations with WCS in Colombia to create a monitor program for zero cacao deforestation actions. But this is just quite soon, so more to come very soon. And that's it. Thank you so much for coming.